So here we have SLOs of this video session. State the composition of clean, dry air as approximately 78% nitrogen and 21% oxygen, O2, and the remainder as a mixture of noble gases and carbon dioxide, CO2. State the source of each of these air pollutants. Carbon dioxide from the complete combustion of carbon-containing fuels, carbon monoxide and particulates from the incomplete combustion of carbon-containing fuels, methane from the decomposition of vegetation and waste gases from digestion in animals, oxides of nitrogen from car engines, sulfur dioxide from the combustion of fossil fuels which contain sulfur compounds. Let's start with the composition of clean air. Air is a mixture of gases that makes up the atmosphere of Earth. Clean air contains nitrogen, oxygen, carbon dioxide, noble gases, and water vapor in air. Now, nitrogen, it makes up 78% of the air, oxygen 21%, carbon dioxide 0.004%. It's written wrong. 0.04% is wrong. So, pollution is the presence of harmful substances. Air pollution is the presence of pollutant gases in the air. A pollutant is a substance that causes pollution. These pollutants are carbon dioxide, carbon monoxide, methane, oxides of nitrogen, ozone, sulfur dioxide, unburned hydrocarbons, and lead compounds. Now, source of carbon dioxide. The source of carbon dioxide is through respiration, fermentation. Fermentation involves the conversion of sugar into alcohols, decay of organic matter or decomposition of organisms, combustion of carbon compounds or combustion of fossil fuel, or combustion of, you can write a name of any fossil fuel. Carbon dioxide is also produced during the decomposition of limestone. Limestone, you know, it's calcium carbonate. You can either write calcium carbonate or limestone. Both are correct. It's also produced from increasing temperature of the oceans or removal of dissolved carbon dioxide. It's also produced during volcanic eruptions. Carbon monoxide is one of the poisonous pollutants of air. It is considered a pollutant because it can kill living organisms. The main source of carbon monoxide is factories which burn carbon-containing fossil fuels. Remember, it's produced during incomplete combustion of fossil fuels. Last form of pollutant gases. Due to limited supply of air, unburned carbon escapes as gaseous hydrocarbons. Other pollutants include dust, smoke, and lead compounds. Large particles will settle quickly, but small particles remain suspended in air for a long time. The source of dust particles, building work, mining activities, forest fires, and the incomplete combustion of fuels, that's unburned carbon, is produced. Or methane gas. Let's talk about methane gas. It's formed by animals when animals eat and digest their food. Methane is produced. It's released to the atmosphere by animals. When plants die and decompose over many years, methane gas is also produced by decomposition by bacteria. Nitrogen oxides are formed at high temperatures during lightning activity in the air as a result of nitrogen and oxygen reacting. In cars, engines have a very high temperature, or you can say spark. This creates a chance for nitrogen and oxygen present in the air in the engine to react, forming nitrogen monoxide. Now, here's the reaction equation for the formation of the other oxides of nitrogen. 2NO plus O2 gives 2NO2. NO2 is an acetic oxide.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring, from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
The gas produced by car engines is ozone. It's formed by when an electric spark passes through air, oxygen at ground level. Ozone and nitrogen reacts with ultraviolet radiation in sunlight and produces a photochemical smog. What is photochemical smog? It's a haze in the atmosphere accompanied by high levels of ozone and nitrogen oxides caused by the action of sunlight on pollutants. Sulfur dioxide, SO2, is considered a pollutant. It's a non-metal oxide, that causes acid rain. It contributes to acid rain. So how it's produced? Sulfur dioxide, it is the product of two processes. One of these two processes happening. One is the combustion of fuels containing sulfur. Fuse contains sulfur, and other is during volcanic eruptions, also produced during the extraction of metals from their sulfide ores, such as zinc sulfide. State the adverse effects of these air pollutants. Carbon dioxide, high levels of carbon dioxide leading to increased global warming, which leads to climate change. Carbon monoxide, toxic gas, particulates, increased risk of respiratory problems and cancer. Methane, high levels of methane leading to increased global warming, which leads to climate change. Oxides of nitrogen, acid rain, photochemical smog, and respiratory problems. Sulfur dioxide, acid rain. Describe how the greenhouse gases, carbon dioxide and methane, cause global warming. Limited to absorption, reflection, and emission of thermal energy, reducing thermal energy loss to space. You see, the sun sends energy to the earth in two forms: light and heat. Some of this heat energy reflects back to space, but some of this energy is also trapped inside the earth. We call this the greenhouse effect. Carbon dioxide and methane are the main greenhouse gases. The greenhouse effect poses a threat to the world nowadays. Greenhouse gases, especially carbon dioxide, have increased in amounts in the atmosphere due to activity of humans. Lots of fuel combustion is taking place around the world, increasing the levels of carbon dioxide while trees are being chopped off to make use of, instead of leaving them, to replace CO2 with oxygen. There's an increase in the levels of carbon dioxide in the atmosphere due to these activities. As a result, there is absorption, reflection, and emission of thermal energy. This also reduces thermal energy loss to space. Global warming is happening, and we are all experiencing a rise in the temperature of the Earth. And the increase in the temperature of the Earth is due to the increase in the levels of greenhouse gases. Now, let's talk about the effects of global warming on the Earth. The North and South poles are made up of ice, and due to global warming, this ice is melting. As a result, the sea level rises. The sea temperature will also rise, causing death to marine lives. We are also watching other natural disasters occurring around the world, such as hurricanes and heavy rains. Humans could prevent this by reducing the combustion of fossil fuels and leaving forests to live. Carbon monoxide of CO is one of the products of incomplete combustion of fossil fuels. This gas is poisonous, and once it reaches inside the human and animals' bodies, it blocks the transport of oxygen to different parts of the body. As a result, animals and humans die of suffocation. Adverse effects of the particulates in the air. There will be increased risk of respiratory problems and cancer. And this can irritate the lungs, causing bronchitis and other lung-related diseases. The problem associated with nitrogen dioxide is similar to that of sulfur dioxide. It rises up in the air and mixes with rainwater, forming nitric acid. This causes acid rain. Nitrogen oxides are also responsible for photochemical smog and respiratory problems in humans and animals. To treat this issue, cars are now fitted with devices called catalytic converters, which remove nitrogen oxides. Now let's talk about sulfur dioxide. Sulfur dioxide rises in the air from the chimneys of factories and it mixes with water vapor from clouds and air. This results in the formation of sulfuric acid, H2SO4. When it rains, rainwater which falls becomes acidic. Acid rain causes death by killing aquatic life, killing plants, or deforestation. Dissolves metal structures, chemical weathering of carbonate rocks and buildings, or reacting with limestone from buildings and sculptures. Corroding it, smog, worsen asthma, breathing difficulties, or may also cause lung cancer. And explain strategies to reduce the effects of these environmental issues limited to climate change, planting trees, reduction in livestock farming, decreasing use of fossil fuels, increasing use of hydrogen and renewable energy, for example, wind, solar. Acid rain, use of catalytic converters in vehicles, reducing emissions of sulfur dioxide by using low sulfur fuels, and flue gas desulfurization with calcium oxide. Explain how oxides of nitrogen form in car engines and describe their removal by catalytic converters. For example, 2CO plus 2NO gives 2CO2 plus N2. Describe photosynthesis as the reaction between carbon dioxide and water to produce glucose and oxygen in the presence of chlorophyll and using energy from light. State the word equation and symbol equation for photosynthesis. Trees absorb carbon dioxide, CO2, during photosynthesis, reducing greenhouse gases. They release oxygen, O2, which is essential for respiration in humans and animals. Photosynthesis in trees helps maintain the atmospheric balance of CO2 and O2. Trees act as carbon sinks, helping to combat global warming and climate change. Trees improve soil quality by contributing organic matter through leaf litter. Trees influence the water cycle by transpiring water vapor, contributing to rainfall. Livestock farming produces large amounts of methane, CH4, a potent greenhouse gas. Methane contributes significantly to the enhanced greenhouse effect and global warming. It helps decrease deforestation, which is often done to create grazing land. We get methane, petrol, kerosene, diesel from fossil fuels. Decreasing the use of fossil fuels reduces air pollution caused by harmful gases like sulfur dioxide and nitrogen oxides. It also lowers carbon dioxide emissions, helping to reduce global warming. Less acid rain, which protects soil, water, and buildings. Improves public health by reducing respiratory and heart problems, slows down climate change and its harmful environmental effects. conserves non-renewable fossil fuels resources for future generations, encourages the use of renewable energy sources like solar and wind, reduces dependence on imported fuels, improving energy security. Now let's talk about reducing the effects by increasing the use of hydrogen as a fuel in vehicles. Hydrogen is a clean, renewable energy source. Hydrogen fuel produces only water when burned. So it is non-polluting. The water produced is pure and can be used for different purposes. The use of hydrogen as a fuel helps reduce greenhouse gas emissions like carbon dioxide. It can also be used in fuel cells to generate electricity efficiently. Using hydrogen reduces reliance on fossil fuels. Another strategy is to increase the use of renewable energy resources like wind energy, solar energy, etc. These reduces greenhouse gas emissions, helping to combat climate change, decreases air pollution, improving overall air quality and health, lessens dependence on fossil fuels. Catalytic converters are installed in vehicles to reduce harmful gases like carbon monoxide and nitrogen oxides. Catalytic converters convert toxic emissions into less harmful substances like carbon dioxide and nitrogen. They help in reducing air pollution from vehicle exhaust. It improves overall air quality and public health. Catalytic converters support efforts to reduce environmental damage and smoke formation. Another strategy is to reduce the emission of sulfur dioxide by using fuels containing less sulfur. This reduces the formation of acid rain, which harms plants and aquatic life. It helps protect buildings and monuments from acid corrosion. It also improves air quality by lowering harmful gas levels. It decreases respiratory problems caused by polluted air. In this way, it also supports environmental protection and sustainability efforts. In fuel gas desulfurization, sulfur dioxide and sulfur trioxide treated with calcium oxide to produce harmless neutral salts. In this way, we can also reduce the emission of sulfur dioxide and sulfur trioxide into the environment. Here are the word equations for these reactions. You see, neutral salts are produced in each reaction. Now, in vehicles, the catalytic converters contain catalyst rhodium, which catalyzes the reaction between oxides of nitrogen and carbon monoxide to produce harmless gases, that is, nitrogen and carbon dioxide. This catalyst works best at a temperature of around 200 degrees centigrade and also removes unburned hydrocarbons. Here is the reaction between carbon monoxide and carbon monoxide, nitrogen monoxide and carbon monoxide. As we can see that carbon monoxide is oxidized to carbon dioxide and nitrogen monoxide is reduced to nitrogen gas. So this reaction is an example of redox reaction. The reaction is a redox because carbon monoxide gained oxygen, while nitrogen monoxide has lost oxygen. Therefore, carbon monoxide will be acting as a reductant or reducing agent, and now nitrogen monoxide as an oxidant or oxidizing agent. This reaction can also be explained in terms of change in oxidation numbers. In carbon monoxide, oxygen is more electronegative than carbon. Recall the trend in electronegativity for this. And its valency, I'm talking about the valency of carbon, its valency will be its oxidation number, that is -2. This will be the oxidation number of oxygen. Therefore, carbon must be carrying +2 as its oxidation number. So for carbon, oxidation number increases from +2 to +4. The change in oxidation number will also be explained for nitrogen. In nitrogen monoxide, as oxygen is again more electronegative than nitrogen, then it must be having its valency as its oxidation number, which is -2. And nitrogen will be carrying +2 as its oxidation number. Therefore, for nitrogen, the oxidation number decreases from +2 to 0. Therefore, nitrogen monoxide and carbon monoxide are released as non-toxic or harmless gases in the air. Now, let's talk about photosynthesis. The term photo stands for light. In photosynthesis, plants make their food, which is glucose, in the presence of light. You can also say that this reaction is catalyzed by light. During photosynthesis, carbon dioxide and water reacts to form glucose and oxygen gas. The green pigment, chlorophyll, converts light energy into chemical energy. Here's a word equation for photosynthesis. Carbon dioxide reacts with water to produce glucose and oxygen gas. And the symbol equation for this reaction is 6 moles of CO2 plus 6 moles of H2O gives 1 mole of C6H12O6 plus 6 moles of O2.